Hi, this is Greg Smith from the Department of Applied Science and the Neuroscience program at the College of William and Mary. The cellular biophysics and modeling students have been appreciating these screencasts explaining how to do some of the homework problems. So I thought I'd do an example of how you can intuit the direction of flow in the phase plane when you're given null lines and you're told that one of the variables is faster than the other. And so for this example, which is somewhat like your homework, I have the XY phase plane indicated in this corner. This is telling you that the dependent variables of our nonlinear system of ODEs are X and Y, and this is the arrows here are telling you the direction which you should go when X or Y is increasing. So this is the conventional coordinate axis for the upper right quadrant of the plane, of the Cartesian plane. And then what has been indicated here is that in this region of the phase plane, the flow is in a general sense to the northeast, meaning that Y is increasing and X is increasing. Then I've plotted the X null line in blue and the Y null line is in red. Now there's a number of ways to begin, but I think that what we'll do is simply try to figure out the general direction of flow in each of the quadrants. So remember that this arrow pointing to the northeast, what it really means two things. It means that that the direction of flow for X is increasing. And it also means that the direction of flow for Y is increasing. Now these arrows are not meant to represent the actual direction that a solution would go, that a trajectory would go. They're just indicating qualitatively whether X or Y are increasing or decreasing. And in this region of the phase plane, we're told that both X and Y are increasing. Now, it makes a lot of sense that if Y is increasing here, and that means the rate of change of Y is positive, so the right-hand side of the differential equation for Y is positive. And then this line is telling us that the rate of change of Y is 0. Then when we cross the Y null line, the rate of change of Y should be negative. And the Y null line is really dividing the phase plane into simply two pieces. And when you're above the Y null line, we expect Y to be decreasing. And when we're below the Y null line, we expect Y to be increasing. So I'll indicate that in each of the regions of the phase plane that we'll be considering. So I see that I got this second arrow wrong, so let me turn it around. We're above the Y null line, so the flow will be down here. We're above the Y null line here, so the flow will be down. And this is already indicated as being flow upwards below the Y null line here, and we're also below the Y null line in this region. And then this is contiguous with this region over here. Okay, now as far as X goes, if X is increasing in this region, then when we cross the X null line, X should be decreasing. Okay, so X is decreasing here because we're moving from this region to this region, we've crossed the next null line. Similarly here. This is also going to be decreasing X because we're on the right side of this cube, of this, weirdly shaped x null line. Here we're moving, x is increasing, so we haven't crossed the x null line when we get to this region, so x is increasing here. X would be decreasing here because we're on the other side of the x null line, and here we would have x increasing. And I think I got them all. So now let me sketch in sort of the yellow arrows in case for some of you this might be more intuitive. You could sort of only draw the yellow arrows if you're able to do that, sort of calculating the direction of x and y in one step. All right, so there we have it. So we generally understand the direction of flow in the phase plane. And now it can be helpful to remember that in order to cross an x null line, we must be moving in the vertical direction. So for example, if we were at this point, we'd have to be either moving upwards or downwards because the rate of change of x is 0. So x can't change, and that means that we must be going vertically. So let me try to draw a vertical line here. And we also know that if we're at this point, for example, we not only know that we're moving vertically, but we know that x is supposed to be increasing in this region of the phase plane. So I'm sorry, we know that y is supposed to be increasing in this region of the phase plane, so we know that the trajectory should be going up. And that'll be true, for example, here. I'm going to just go through now and pick some more points and indicate the direction of the flow as we cross the x null line vertically. Over here, the rate of change of y is negative. So we would cross vertically in the downwards direction. The rate of change of y is positive here, so we would cross vertically the x null line in the upwards direction. And here would be another example where we cross downwards. To put some arrows on the y null line, what we can do is just go to the y null line and realize that we should be crossing horizontally. And the question is, do we cross in the way where x is decreasing or in a way where x is increasing? And to see that, I can identify the fact that I'm in this region of the phase plane, x is supposed to be decreasing, so the arrow should go to the left. Whereas down here, if we crossed horizontally, the arrow would go to the right. Because we're to the left of the x null line. Over here, we're to the left of the x null line, so we would be going to if we crossed the y null line horizontally, which would be a little bit hard to do, but if we did, it would be going in that direction. And then in this region, we're on the other side of the x null line, so if we happen to cross the y null line, we would move towards the left. You can see that since the y null line is so close to horizontal here, it would be quite hard for trajectories to cross. So that is an example of just how you would sketch out the direction of flow in the phase plane. And in the second part, we'll show you how you can sketch some trajectories onto this phase plane.